Okay. So I have also started the recording. Good afternoon, everyone. I'll quickly introduce myself. I am Nitin Nyati. I'm a TAM in Mumbai, handling some of the BFSI customers. I also have my colleague Siddharth on this call, who will also be moderating this along with me.
Yeah.
So first of all, thank you everyone for joining the TAM R&D webcast series. Chidru, can you put your phone on mute? I hear a lot of people.
Okay.
It's still not muted. Hello, Chidru. Okay, I'll start. So thank you everyone for joining the TAM
Yeah,
R&D.
can you?
Okay, let me try and put you on mute. Okay. Yeah, so third time. Thank you everyone for joining the TAM R&D webcast series. This is our third webcast this year. And as you all know, the topic of today's webinar is VMware Cloud on AWS architecture overview and use cases. So VMC on AWS is new in India. It just went live this month, and there is a lot of excitement around this. So we just thought that an overview session on VMC on AWS would be a good way to kickstart the TAM webinar again. So today we have Chidrupa and Anshuman, who are the presenters for this session. Both Chidrupa and Anshuman have expertise on SDDC solutions, and they've also presented in VMUGs across different regions. So before we start this webinar, some basic housekeeping that we should be aware of. All of you except the presenters will be on mute during the whole session. So if you have any questions, you can put that in the Q&A window in the chat. We'll also try and have 5 to 10 minutes of Q&A in the end, so you guys can unmute yourself and then ask questions directly to the presenters. The session is getting recorded, so you'll get the recording from your respective TAMs. So in case you're not able to attend the some part of the session, then do not worry. This is getting recorded, and we'll send the recordings across to you. So without further ado, I'll hand over to Chidrup to kickstart this webinar. Over to you, Chidrup.
Yeah, thank you so much. Hello, everyone. Welcome to the session. Can you hear us clearly now?
We can hear you.
Yes, we can hear you.
Okay, thank you. Yeah, welcome to the session. Today we're going to talk about VMware Cloud on AWS. My name is Chidrup, and I'm part of Core Platform Business Unit, which is part of R&D. Today we have our colleague Anshuman as well with us, who's going to share the slides. So, yeah, let's see the agenda today. Today we're going to talk about VMware Cloud and its use cases, major use cases. Why do we require VMware Cloud on AWS? And also we're going to talk about SDDC configurations and the major building blocks of SDDC configurations, which is vSAN and NSX. And also Anshuman will get us through the slides where, through which we can see how we can migrate the workloads from on-prem to on-cloud and vice versa. Right? So there were so many challenges what customers started facing when they started moving their workloads, right? So we were not first in the game. In fact, Microsoft, Amazon, and Google were already providing the cloud services. So that is when customers had some requirements by which, they wanted to move their workloads to the cloud. It can be an application specific, or it can be anything. So when they started moving their workloads to the cloud, they started a lot of challenges. So some of the challenges are presented here. If you see, the first thing is operational inconsistency, right? So when they move their workloads, they don't get operated as they're operated on the on-prem. They're totally different. The environments are totally different. For example, you can convert your virtual machine. Say you have VMware's virtual machine. You can convert that VM to Amazon's machine instance, right? So you can do that and start using your VM. But that's not end of the story, right? You have to start managing it. You have to know the ways like how do you migrate and completely manage end to end, during your day-to-day routine. So that part is totally different here on the cloud. And then the existing skill sets and tools, right? All of a sudden, whatever the tools they had on premises have become obsolete, right? With the new set of APIs, what these cloud providers generally provide, those are totally different. You have to scrap your tools and rewrite the scripts, rebuild the tools right from the scratch, and also you have to build your skill sets again, from the bottom up, with the new APIs, whatever they provide. So the tools are basically essential to control, manage, and secure the workloads. So you have to rewrite your tools from the scratch. You have to rebuild your skill sets according to the new set of requirements. And also when we talk about SLAs, right, enterprise class application level SLAs, it can be different from cloud provider to cloud provider. One cloud provider can say that 4 minutes of continuous downtime is treated as an availability. But you have to really see, whether your application can cope up with 4 minutes of downtime. If not, you have to check somewhere else, which means that you have to check some other cloud provider. Similarly, we have the applications, high performance applications like mission critical applications, and which requires high network bandwidth. So these applications, sometimes what happens is when you place these applications on the cloud, they're not compatible. Which means that you need special hardware and special bandwidth channels to support these applications. So these are some of the challenges what customers went through when they migrated the workloads to different cloud providers. With all these challenges, what VMware thought us, why can't we provide a safe and secure environment which has the same level of operability similar to on-prem, right? So that's when we have partnered with Amazon. Why Amazon specifically? Amazon is simply best in the class when you talk about the native cloud services. We have partnered with Amazon. With that partnership, what we have done is on AWS global infrastructure, we have placed our full stack. So when we talk about the stack, we have ESXi and we have vSAN, we have NSX, right? When you see the ESX, right, it has a dedicated hardware. We don't use nested hypervisors here. We use the bare metals which were provided by AWS global infrastructure. That way, it's a complete full stack. So then moving on to vSAN, again, right, we spoke. vSAN requires all-flash configurations, which is a special hardware that is possible only when you have bare metals. That's how Amazon is so useful in this partnership. And then we have NSX also on the other hand, which is one of the best solutions, network solutions in the market today. So if you see, all these bits and pieces are managed by vCenter Server. So we have the full stack placed on AWS global infrastructure. On the other hand, we have our on-premises data center as well, right? So you may have a question saying that, if a customer has both the environments, how does he manage, right? So you see the dotted line here on this picture, it says it all, right? So single vCenter instance can have the same, both the inventories of on-prem and on-cloud. It's a single pane of glass, like through which customer can see or view, operate both the inventories. On the other hand, we have vRealize suite, vSphere integrated containers, ISV ecosystems, all are possible on this hybrid system. We also have native AWS services. On the other hand, customers would have already got familiarized with some of these native AWS services. They also can utilize these services like Elastic Cloud and Simple Service Storage and Relational Database Service, which are provided by Amazon. We have some interfaces through which you can start using these native services as well. So if you see the whole picture, this is kind of an hybrid model we provide to the customer. It is really safe and secured, and it has the same level of operability like what you get it on-premises. Yeah, well, let me put this question across to the forum. So when we talk about purchasing a new mission, you have to go through a lot of purchase tickets, a lot of approvals. And once the mission is placed in the laboratory, you need to contact the IT team, to install the necessary softwares on it, right? So generally, how many days it take, right from the approvals to the stage where you start using the mission? In some of the forums when we asked this question, so some of the customers said like 20 days, 30 days, and even 40 days. So 20, 25 days is good enough. But the market survey says it takes 86 days, like up to 86 days on an average, right? If you see the complete industry, it may take up to 86 days. But what VMware says that, I'll give you the mission, the same mission, which has the necessary softwares installed on it in just 10 minutes. So that is really cool thing. That's the advantage of cloud. And we are VMware as a cloud platform. We do that. We provide that platform where customers can easily add up the missions or resources on the fly. We'll see how do we do this in in the further slides. Yeah, and also due to some governance rules or regional specific applications are some government rules, compliance rules, right? Due to which you may think that you need to place your data center in the same region wherever you're located. So if not, right, you lose things like utilizing the capabilities of cloud and all, right? So when we talk about the locality, you don't have to worry about that. VMware is covering all the regions wherever the Amazon is placed. Currently, we have 12 regions. And recently, we have pulled up the Mumbai's data center as well, Mumbai Cloud thing. And we have given the roadmap here. I'm not going to get through all this quarterly plan. Maybe once we share the slides, you guys can take up a look. Right, so let's move on to the use cases. This is where we need to spend some time and analyze and see how do we get through the customers and make use of the cloud. The first one is cloud migrations, right? How does it happen? So in what cases customers can move to the cloud? It can be an application specific, right? So if you see, Amazon has a lot of applications provided on the cloud. So one such example is Amazon's Redshift. It is a data warehouse application which requires to run ETL jobs for the data sync from one end to another end, right? So when you want to really use of Amazon's Redshift, you can't really place your application on the cloud, sorry, on the on-premises and operate it on the on-premises. When you run the ETL jobs, the time synchronization is huge. Like, you don't have to wait till such a long times to sync up the data to your data warehouse application. So what Amazon suggests is you have to move your application to the cloud in order to use all the capabilities of Redshift. So we have similar applications, right? And so many applications in place, which suggests that you need to have your applications on the cloud. This is one example where a customer can think, moving to the cloud. And the second one is infrastructure refresh, right? So when we talk about infrastructure refresh, say a customer has a laboratory where all the missions are getting to the end of their life. In such cases, what he can think is like, he can build a new set of servers, or he can build a new data center by keeping all the resources in place. But that scenario is like, again, the manageability aspect will be increased. In such cases, he can just think about the cloud aspect and move to the cloud. Everything, all the data center, all the missions centered to the cloud. He can get away, easily can get away with the manageability aspect there. And the third one is footprint expansion. Footprint expansions can happen with anybody. Say you're placed in India and you wanted to expand your business to China or some other country. In such cases, you may have to think about building the whole new data center in the other region. So this is where the customer can think about VMware Cloud on AWS and say that, no, why can't I go ahead and use the cloud which is already existing? I really don't want to have the time or enough resources to manage the physical servers. So let's go the cloud way. So you can think in many ways to move his applications whenever or expand his business to different regions. That is one example where footprint expansion can happen. And also we have on-demand capacity, right? So we all are aware of seasonal spikes. There are many organizations today, the online retailers, which face on-demand spikes, right? Whenever the spikes happen, you need capacity immediately. So one way is like, you need to be prepared beforehand and, keep all the resources ready. And, once the spikes are down, like the situation has become normal, you keep the missions empty, like nobody utilizes those missions. So which is waste again, right? Waste of resources, money, time, everything. So in such cases, you can start thinking of the capabilities, cloud capabilities. So what happens on the cloud is whenever you have your data center on the cloud, and when you meet the spike, right, on demand capacity is added automatically with the elasticity what a cloud has. For example, you wanted an extra mission when you're dealing with the spikes. Mission gets added automatically. We'll see how it can happen in the further slides. And the other example is test or development cases, right? Whenever the development teams, have their projects started, they always have the resources more than what they require. In fact, the resources more than what they require for the production. So in such cases, what you can do is you can start up a data center in the cloud, and you can just finish up your test and dev scenarios, execution of test and dev scenarios. Once it is done, you can just get away with the complete hardware. You don't have to pay. So the cloud is like, pay per usage model, right? So whenever you use it, you pay. And whenever you don't use it, you don't have to pay. Yeah, the last use case what we see here is disaster recovery. Disaster recovery is a service on the VMware Cloud on AWS. We provide it as a service. It is based upon VMware's SRM only, Site Recovery Manager. Whenever a customer think about a new DR, he can think about the cloud capabilities, and he can place an order for the new DR. And also he can think of replacing the existing DR from the on-premises to cloud, and also he can complement the existing DR, right? So he can go ahead and build another disaster recovery site on the cloud, which can be a complement for his existing disaster recovery server. So what does SRM does generally, right? The SRM is an on-premises application which provides the capabilities, the replication capabilities between primary and secondary server. Building a secondary server is not a small thing. You have to have storage capacity which has the capability of replications, which is a special hardware. And also you have to have a lot of space, rack space. You have to use a lot of electricity. You have to use many resources, manpower, everything for just, instance where, you're waiting for a disaster to happen, which is again, a lot of resources wasted there. So instead of that, what you can do is you can think about cloud. You can start a 4-node cluster on the cloud as a disaster recovery site. And you can slowly increase the number of hosts or the clusters, depends on your requirements. So in this way, you're not paying extra. Whenever it happens, you're going to pay whenever it happens, right? So again, it is a pay per usage model. When it is not used, you don't have to pay anything there. So these are the major use cases what we have gone through. We through the upcoming slides, we can see like how these scenarios or these use cases are achieved. Now, my colleague Anshuman will take us through the upcoming slides. He will talk about the major building blocks of SDDC, which is vSAN and NSX. And also he is going to talk about the hybridity part, like how we move the workloads from on-premises to cloud and cloud to on-premises. So before I wind up, let me give you some pointers here. We have a release notes which is mentioned here. We're going to share the video and we're going to share the slides later with you all. You can go through the release notes. Release notes, you have the categories like available, preview, developing, and planning. Based upon this, you can get to know what is planned and what is available in VMware Cloud on AWS. And also we have FAQ pointers. in which you can see a lot of FAQs and get the answers in there. And also, VMware is being transparent to our VMware Cloud customers. We have provided the complete roadmap. You can open it and see the roadmap as well. Well, thank you all. Passing it on to my colleague Anshuman.
Hi everyone, I am Anshuman and work for vSphere Solutions team. So thanks Chidrupa for the introduction. Till now we saw what was the motivation behind building these cloud services. So in this session I'll take you through what are the different components and configuration maximum which are supported in VMware Cloud on AWS. And we'll see how we can leverage this cloud to make our applications which are running on-premises more resilient and scalable. So when we spin up a data center on VMware Cloud on AWS, we get an SDDC which comprises of three components, vSphere, vSAN, and NSX. So now let's see what a cloud SDDC configuration looks like. So in SDDC, we can have up to 10 SDDC which are supported per organization basis on VMware Cloud on AWS. Each SDDC can have minimum of 1 to maximum of 10 clusters. And each cluster can have a minimum of 3 ESXi hosts to a maximum of 16 ESXi hosts which are supported inside SDDC. While deploying SDDC, we also deploy a management resource pool where we deploy our management chunks that we'll take in the upcoming slides. So now we'll see how a VMC UI, typical UI console looks like. So when you will get a VMware Cloud on AWS account, you can log into this VMC console. So this VMC console will have an initial dashboard where you will see what are the SDDCs you have defined and which regions you have defined an SDDC or deployed SDDC, what configuration the SDDC has. So in this example, we have deployed 2 SDDCs, one in US West region and one in Sydney Asia Pac region. And then we can drill down to the internals of SDDC once we click on it. So in this case, the US West region SDDC has 2 clusters and each cluster has 3 hosts. This bring us to the capacity of 64 TB and 3 TB of memory. So if you also will notice there are small buttons or icons on the dashboard where you can choose to perform add host and remove host operations. So in typical environment, in case you have to add or remove host, you need to log into your vSphere and then perform the operation. Here, just by clicking on add host operation, the VMC UI will give you a pop-up where you can choose how many hosts you want to add on the cluster. And within 5 to 10 minutes, the host will be added in your cluster. It is as simple as this, just opening a UI pop-up and then filling the values and the host is getting added to a cluster. Now, what all happens in the backend once you fill up this form and click the submit the request? The one host will be pulled from your VMC AWS resource pool. The ESXi host will be booted up. It is configured as per your current SDDC configuration, which means it does take care of doing all the storage networking configuration on that ESXi host, and the host will be added to your cluster. And after that, all the resources which are there in the host will be consumed by your cluster and it will reflect in the cluster. So those hosts will be ready for production within 5 to 10 minutes. We also do have a couple of services which we are already enabling on VMware Cloud on AWS. So we have DRS already configured and enabled on VMware Cloud on AWS. We spoke about automatic configuration. So this feature, like we spoke already, the host where we want to add the host, all the configuration part of adding the host, the vSAN, NSX is done with the service itself. And then we have a very cool service, automatic hardware remediation. So in case there is a failure in your data center, say for instance, a host down, since DRS is already enabled, the VMs will be moved out of the host. A new host will be pulled from VMware AWS host resource pool. Automatic cluster configuration service will do all the configuration which is needed on the host, and the host will be brought up into a cluster and ready for consumption. So this all happens in the automated way. No manual intervention is required. The automatic hardware remediation service will runs on your cluster and keeps on monitoring the status of each of the hosts of a cluster. And in case it sees any of the hosts has went down, it will take care of throwing off that host and bringing a new host inside your cluster or STDC. So recently we had a feedback from some of the customer who has completed 6 months of subscription of VMware Cloud on AWS, and he was happy to report that he didn't find any hiccup or any host going down in your VMware Cloud on AWS SDDC. But on the back end, when we saw the logs, we observed the 3 hosts got p-sorted and went down. And automatic hardware remediation service has taken care of moving the VMs and doing everything in such a useful manner that user was not even able to recognize, or he didn't even come to know the host was down or it went down. So when we were looking through the introduction slides, right, we saw that there was a use case where we talked about on-demand data center expansion. So we have a specific feature to address this use case, which is Elastic DRS. So in the case of Elastic DRS, whenever there is a demand, since we are on the cloud, we can leverage the cloud to add the new host in the cluster. And then the resource capacity increases on the cluster and the application runs seamlessly. So in Elastic DRS, we can choose to have this configured on your STDC and have your STDC configured for your best performance optimization or your low cost optimization. And in case of high demand, the service will pool a host from AWS resource, add it to a cluster to meet the current resource usage and demand. And then once the demand goes down, it will throw the host or move it out from a cluster. And that also happens in an automated way. So you don't have to, so you just can enable the service, and then you can easily scale up or handle the on-demand or high demand on your STDCs.
Anshuman, there is a question in the Q&A window. So anyone from your team would like to answer it?
The question is it a proactive HA? So are we talking about Elastic DRS here? Yeah, the question is it a proactive HA? So I'm not getting the context. Can someone expand this question? Is he talking about the Elastic DRS?
Okay, so the question is from Shafiq. So he's asking, I hope we can add, this is an existing on-prem VMware cluster. So I'm sure he's talking about DRS, Elastic DRS as well. So yes. So he's asking about the same thing. So can you please double click on a little bit about Elastic DRS for all of us?
For some reason, we are not able to see the question. Can you repeat that, Nathan, please?
Yeah, so Chidrup, it's not there on the chat, it is there on the Q&A window. So you will also see a Q&A window just before the participants.
Oh, got it.
Beside the participants.
Yeah, got it. I hope we can add this in existing on-prem VMware cluster.
So he's referring to Elastic DRS.
Got it.
Yeah, so we can enable this on existing on-prem VMware cluster. But Elastic DRS is already supported for VMware Cloud on AWS services. So in case you opt for the cluster where you are using a VMware Cloud on AWS subscription, that is where you can enable the services of Elastic DRS. The HA and other functionality are supported on on-premises, but Elastic DRS is specific to VMware Cloud on AWS services. So I hope I have answered the question. Can we move to the next slide?
Yes, please, you can move.
Okay. So now we'll see what are the other components apart from vSphere which get deployed as your SDDC, and what are the configuration in this. So initially the vSphere was deployed, then we have a vSAN configuration which is done on your SDDC for a storage. So vSAN, we have all the flash disk, and we on each host we create 2 disk group, one for capacity and one for cache tier. And we can have, if we have a maximum 16 hosts inside a cluster, we can have up to a 160 TB of raw storage or raw capacity on your cluster. Like I said, initially as a part of SDDC bring up, we deploy a management resource pool. Inside that management resource pool, we deploy some of the management pieces like vSphere and NSX, and we have access to those management resource pool and pieces, and it consumes even less than 1% of a data store capacity in case of a 3-host cluster. And we need access to this resource pool because we will take care of upgrading, patching, doing all the operations on your SDDC by ourselves. So you even don't have to take care of performing an upgrade or patching maintenance on a VMware Cloud on AWS. We enable a health services on your vSAN. This is just to monitor in case there is a disk group which is going down or vSAN health is not up to the mark, and then we'll start sending the notifications to the user on VMC console about the warnings or any error messages or anomalies in the behavior if we see. So since this AWS is also supported across the region, we have a feature called stretch cluster. While deploying the SDDC, we can select, we can choose the option to deploy the cluster across different availability zones or stretch it across the multiple availability zones. This will help us in protecting the SDDC in case there is a zone failure. So if you choose this option, your SDDC will be segregated into 2 different zones, and it will be active zones. So all the data will be copied using HA and or vMotion techniques or replication technologies, and the synchronization or replication will happen across the SDDC. So once, if there is any failure of the availability, all the VMs will be powered on in a secondary AZ. And since we are internally using the HA functionality of vSphere, the RPO and RTO time is equal to the HA restart, which is 0 in this case. So this will be more helpful in case we are having an application in which we want a resilient factor. So you don't have to take care of resiliency of the application. The moment the zone goes down or application goes down, the other zone will be brought up and application will be up within fraction of seconds. So no changes has to be done on your traditional application or workloads which you are running on your on-premises. And we can choose to use this stretch cluster multi-AZ feature. We'll talk about the NSX component, which is already deployed as part of SDDC configuration. So NSX is primarily will be deployed on your AWS infra. So AWS infra will provide ENI network interface, elastic network interface of 25 GB bandwidth, and using that interface we deploy NSX over it, and we take care of all the networking aspects in the VMware Cloud on AWS using this NSX. So we'll deploy VPN, we'll deploy all the micro segmentation things, and in case we want to have different kind of storage and different kind of your accounts connectivity using NSX, so we can do all that operations. So using this elastic network interface of AWS, by deploying the SDDC, we also get access to a VPC account of AWS. Now using this VPC account, elastic network interface, we can use some of the hybridity solutions in case we already have an on-premises environment and we want to choose to migrate the services or migrate your workloads from your on-premises to on-cloud. So we'll see what all the use cases hybridity solves. So initially we spoke about 3 major use cases, right? Data center migration, in which we had small footprints spread across your data center or spread across the regions, and we can think of cloud as a solution to consolidate all those data centers and then migrate it over VMware Cloud on AWS. Second one was data center expansion, in which we already have a footprint on premises and we want to expand a data center, then we can choose a VMware Cloud on AWS as your secondary or expansion site. Or we can choose VMware Cloud on AWS as a disaster and recovery site. So it will be a secondary site in which you don't have to maintain the whole site as your recovery. In case the disaster happens, automatically a site will be brought up on cloud, and that is when you actually have to start paying. So we can use hybridity to fulfill all these use cases. So let's see how we can leverage the hybridity for these use cases. So before we talk about how do we get our applications on cloud, I mean on our on-premises or current workload application on cloud, let's try to see and understand what do we get if we choose to migrate our existing applications from on-premises to VMware Cloud on AWS. So like we were talking about in the previous slide, VMware Cloud on AWS or AWS will expose the Elastic Network Interface, and using the VPC account of AWS, we will get access to more than 100 plus AWS services. So think about, you have a workload which is running on your on-prem. Now you just migrated the workload to VMware Cloud on AWS, and then you can use all the AWS services on your existing on-premises workload just by choosing them to migrate to VMware Cloud on AWS. After the migration, you can just call all the services which AWS offers. So one of the use case, what it means as an on-premises user to us, right? So one of the use case which I can think of is, assume if you have a log archiving server, an application which just archives the logs, and it is running on your on-premises. Obviously, choosing a vSAN, high performance vSAN storage as a solution for log archiving server application is not a useful or optimized solution. In that case, we can choose to migrate this application from on-premises to VMware Cloud on AWS. And then we can choose to use either Amazon S3 or Amazon EFS, any of these services, just for storing the logs of that application. In case we have say a web server which is running on premises, a workload which hosts a web server on premises, we can choose to migrate that workload to VMware Cloud on AWS, and then we can get high load or auto scaling capability using Amazon EC2 on that application. So you don't have to refactor your application, you don't have to rewrite anything on the application, just move it to VMware Cloud on AWS, and then as per your use case, you can just choose to opt for any of the AWS services. So now let's see how a typical hybrid environment look like. So on the left hand side, I have a typical on-premises data center where I have a storage stack, I have a VDS stack, and of course I have a vSphere. On the right hand side, I have a VMware Cloud on AWS stack where I have a vSAN as my storage, NSX as my networking stack, and of course I have a vSphere which is built on AWS global infrastructure. So now seeing these two different kind of whole SDDC stack, do we really think that migrating a workload from on-premises to on-cloud or vice versa, with having all these different solutions in place in the SDDC possible? So yeah, the answer is yes. We have a solution called hybrid link mode. Sorry. We have a solution called hybrid link mode, using which we can choose to link these two different SDDCs. And once the SDDCs are linked, we can choose to migrate a VM from on-premises to VMware Cloud on AWS or vice versa. We also have some of the content library solution which is already deployed on premises. So we might be having our scripts, our ISOs, our daily uses, library script which we are already using on premises environment. So the moment we choose hybrid link mode to link both SDDCs, we automatically sync the content of the content library from on premises to VMware Cloud on AWS. So we let you use all the scripts or all the ISOs which we're using on premises as it is on VMware Cloud on AWS. So you don't have to reinvent the wheel. just perform the linking between both the VCs, and all the content of the content library is available on VMware Cloud.
There's a question, Anshu, here.
Yeah.
We can use HCX.
So we'll talk about SCX in upcoming slides.
From Amit.
Yeah. So apart from hybrid link mode, we also have a hybrid cloud extension, or SCX, which is offered already, which is offered in VMware Cloud on AWS as a solution for hybridity. We'll also be covering or talking about live migration in case of hybridity. So we can perform or choose to perform the vMotion from on-premises to VMware Cloud on AWS, or vice versa. We also can choose to perform cold migration, existing VMs you power off and then choose to move it across SVDCs. And content library is something which I just touched upon. And then we also have a feature of enhanced vMotion compatibility already supported on VMware Cloud AWS. So as we are moving the VM from one SDDC to other SDDC, there is a high possibility or chances that we are moving the VM from higher chipset version to the lower chipset versions. If we have enhanced vMotion compatibility already available, you don't have to power off your VMs in case it is moving from higher to lower generation version. It will choose the chipset or generation version which it is lying on by itself, and it will continue to run. But the moment you reboot the applications, it will upgrade itself to the supported versions. So before we see what are the solutions we want to choose or opt for performing the VM migrations from on-premises to VMware Cloud on AWS, we firstly need to see how our SDDC looks like, what are the challenges or what are the workloads we are running on SDDC, and bucketize them into 3 different workloads. So we can have a mission critical applications which should not go under a downtime in case we choose to migrate them, like a database application. It should not go under a downtime in case we are moving from on-premises to VMware Cloud on AWS. The other thing could be your some of the applications which are not very critical, which can go under a planned downtime or some downtime in case we choose for moving them, and the application which can go under a planned downtime window. So your web application server could be a low downtime application which will go just under a maintenance window, and it will come up say in a minute or so. And your log archiving server, another server, could be a no downtime application which you can actually power them off and then choose them to migrate over a period of time from on-premises to VMware Cloud on AWS. So once we have segregated all the workloads in 3 different buckets, that is when we can choose for what are the services we want to use on of our VMware Cloud on AWS. So major 2 categories are obviously the mission critical applications which should not go under a downtime. For that we can choose the vMotion technology of vSphere, and then the application which can go under a planned downtime, we can choose them to have a cold migration operation on those workloads. The major of the workloads where we want them to migrate and have a planned downtime window, we can choose hybrid cloud extension, something called hybrid cloud extension as a service, and then choose to perform the bulk migration of those VMs over a period of time. This gives you a window, a downtime window, or a planned downtime window which you can choose, and then so it uses a VMware replication technology. The moment you choose to bulk migrate those windows, it will keep on replicating the data on the window, and when the downtime window opens or it comes, it will just cut off the window from your source and then it power it on your destination, and it uses the hybrid cloud extension for it. Now let's talk more about hybrid cloud extension. So this hybrid cloud extension is natively built into VMware Cloud on AWS, but we can also use it, or it could also be used for on-premises to on-premises VM bulk migration use cases. Typically, lots of product has to be glued together for bringing these kind of solutions in place. So it has its own built-in optimization where it takes care of deduplication and compression. It supports the VM migration in a bi-directional way. We also let you leverage your current internet bandwidth. A minimal bandwidth of 100 Mbps is required if you want to choose to perform this bulk migration over SCX. or you can use Amazon Direct Connect service. So in case you have opted for VMware Cloud on AWS, you can choose to opt for AWS Direct Connect and then migrate the VM across. So like I was saying, it has a built-in scheduler in which you can choose to perform the downtime window for this bulk migration. This kind of functionality is not there in case you are going for a vMotion or cold migration of the VMs. So there you will just select the VM and it will either migrate, as and when the operation is selected. But here it just keeps on replicating the data, and once the downtime window has come, it will just cut off the VMs.
There's a question also. HCX don't support VMs with RDM, so having physical capability, right? So what is the solution for that? HCX do not support VMs with RDM, having physical compatibility. So what is the solution for that?
So if we want to choose for, we can choose for vMotion in that case, right?
Amit, can you repeat the question? Can you elaborate the question, please? Amit Verma. Okay, so he says vMotion also doesn't work. So having physical compatibility, can you elaborate that question? Amit, please. Okay, Vic.
Chidrupa, we can take the.
Okay. Yeah, we can take this question at the end of the presentation.
Yeah, by that time, participants can unmute themselves and they can ask this question. Amit will park this question at the end of the session.
Okay. So like I was saying, it has a built-in scheduler using which we can choose to have a downtime window, and your VM will, so the moment we do a bulk migration using SCX, the VM will have the replication technology. It will keep on replicating the data from source to destination. And the moment the window comes, it will just cut off from your source and then it will power it on your destination. And best part is it is already included in VMware Cloud on AWS solution. So this service SCX is already offered as VMware Cloud on AWS. So let's see how we can enable or use SCX in VMware Cloud on AWS. So if we go to the typical VMC console, under the SDDC dashboard, there is an add-ons tab. Inside that add-on, hybrid cloud extension is one of the add-on service which you will see. And there is an active button. So once you click on the active button, it will deploy all the services or all the components which are needed for a hybrid cloud extension to work. So it deploys the WAN optimization, it deploys the scheduler, it deploys the L2 VPN Connect service, and it deploys the hybrid SCX manager itself. And it will give you a downloading or a on-premises downloading bit. Using that bit or the link, you can deploy the hybrid cloud extension client on your on-premises. And when the client is deployed, you can pair the VMware Cloud on AWS and your on-premises together. And once the pairing is done, you can easily choose to perform this bulk migration operations. So we support the SCX from 5.0 to latest vSphere version which is there. The cold migration in vMotion is supported from 5.5 to the latest version which is available in the market. One more functionality which SCX currently offers is in case we are choosing to migrate the VM from lower to in case we choose to get the VM from lower to higher version, we can also opt for upgrading the VMware tools and hardware version of your VMware virtual machines. So while migrating, the SCX UI gives an option. Do you want to perform the tools and hardware upgradation of your virtual machines? And in case you opt for it, the service of the VM will go under a reboot, and it will perform the tools and hardware upgradation as per whatever is compatible in your source virtual machine where you're migrating. So this is one of the hybrid solution where we can choose to perform the bulk migration. So initially we spoke about hybrid link mode. Let's see what this offers. So one thing I would like specifically to mention is hybrid cloud extension doesn't give a single pane of glass in case you choose to link your both STDCs. So we need to log into the client of SCX and then choose to perform the VM migration. And once the VM is migrated, again the user has to come back to your on-cloud environment, log in and see whether actually VMs are migrated or to use the VMs once they are migrated. The hybrid link mode will provide you that single pane of glass. So in case you choose to opt for hybrid link mode, you can link your both STDCs, say VMware Cloud on AWS STDC and your on-premises STDC. And this STDC, the single pane of glass, will be available under your on-cloud vCenter H5C UI. It also gives you a functionality or a solution in which you can link to different domains. So for example, in VMware Cloud in AWS, the domain is vmc.local and on-premises could be a vCR.local. So we can link both the domains, and obviously it also maintains certain restriction or permission model restriction on your VMware Cloud on AWS. So user can on-premises user cannot perform all the operations as on your VMware Cloud on AWS. In case you choose to go for hybrid link mode, he will have restricted access to the objects of VMware Cloud on AWS. The moment you link the hybrid two VCs using hybrid link mode, we also sync certain data which is there only which is there on premises. So we spoke about content library. Apart from content library, we also sync the tags and categories which you have deployed on premises. We also sync the permissions and other things which are there on premises, and those all are synced and ready to be consumed for VMware Cloud on AWS. Hybrid link mode will supports the cold migration operation, it supports the VM clone operation, it supports the vMotion, and supports the vMotion operation in both the directions. So you can choose to perform from on-premises to VMware Cloud on AWS, the vMotion operation, or vice versa. 100 millisecond of round trip time latency is supported in case of hybrid link mode. And like I was saying, it supports both the bidirectional mode. Obviously, we support enabling and disabling of hybrid link mode. So you can choose to disable the HLM linking or hybrid link mode linking between you both STDCs, and the single pane of glass will be gone. So in this screenshot, we have linked two different STDCs using hybrid link mode. The first STDC, which is vCenter STDC, is your VMware Cloud on AWS STDC, and VCA TMM01 and VCA TMM02 are on-premises STDC. So you see this, after linking, all the STDCs are available under a single pane of glass once we have linked it. And this is an example where we can choose to perform the migrate operation. The prerequisite for cold migration is the VM should be powered off, and there has to be IPsec VPN connectivity between your on-premises and VMware Cloud on AWS. So this is supported from 6.5 and 6.0U3 or later versions. So here in hybrid link mode, the on-cloud or VMware Cloud on AWS user can initiate the linking process. He has to get the credentials, Active Directory credentials of on-premises. Using that Active Directory credential, he can initiate the linking process from VMware Cloud on AWS. The linking process will come all the way through your on-premises. It does the linking, and then user can log into VMware Cloud on AWS to get the single pane of glass. And after that, all the vCenter H5C UI remains same. The operation and usability remains same for the STDC. In case we want to perform vMotion, migrate, clone, anything, the wizard and operation remains same as we are doing for any EMLM or on-premises use case. So it looks like you're moving the VM within your EMLM use cases. So since we were offering the VMware Cloud on AWS services, and for hybrid link mode, we thought there would be be comfortable in sharing the AD credentials to VMware Cloud on AWS account. So that is when we thought of coming up with a solution called as vCenter Cloud Gateway. So vCenter Cloud Gateway is our appliance which sits on premises. This appliance or the gateway is deployed on premises. Since most of the data is residing on premises, the user doesn't have to share the AD credentials in case you want to do the hybrid link mode. He can initiate the linking from on premises itself using vCenter Cloud Gateway. The linking will go all the way till on cloud or VMware Cloud on AWS and establishes the connection. And vCenter Cloud Gateway also gives you the single pane of glass like hybrid link mode was giving. Advantage here is you don't have to share your AD credentials. So and one, it also supports all the operation which a hybrid link mode supports. In addition to that, since this service is linked with VMware Cloud on AWS, we thought why not to manage the lifecycle of this vCenter Cloud Gateway by us only. So the moment you have deployed the Cloud Gateway appliance and linking established with VMware Cloud on AWS, it will keep on syncing the bits which are installed on VMware Cloud on AWS. And moment it sees there are higher bits available, it will take care of upgrading itself by linking or syncing the data from VMC or VMware Cloud on AWS. So obviously it will send you a notification before initiating the patching or upgrade operation, but it takes care of its life cycle by syncing the data from gateway. So you don't have to take care of doing any operation or anything on VMware Cloud on AWS in this case. And gateway also will manage itself. It is a very trimmed version of vCenter server. So it has the application or services which are needed only for the vCenter Cloud Gateway to function, like UI and other sync services which are needed. And you don't have to share the Active Directory credentials in this case. So you just can initiate the linking from source to destination. So now just to summarize, on VMware Cloud on AWS, what we get, the SDDC stack which we get on VMware Cloud on AWS is similar to what we provision on premises, right? In addition to that we get access to all the cloud services like Elastic DRS, RHA, vSAN, and all the cool services, automatic cluster remediation, which we talked about. And we do not have to invest in people for learning the new product or the UI for if we choose to opt for VMware Cloud. And you don't have to take care of SDDC lifecycle. So VMware Cloud and AWS will take care of managing, patching, upgrading itself whenever there are new bits available. It obviously sends a notification and you can choose to migrate or upgrade whenever you have a downtime window. We can choose to also perform or use the VMware Cloud on AWS as a recovery site. So in this case, we don't have to maintain a secondary site or a whole site as your recovery site. In case the disaster happens, that is when actually a SDDC will be brought up and you have to pay. You have to pay accordingly. Before that, it's just a syncing of data on cloud, and there's a very minimal charges for it. We can also link the VMware Cloud on AWS with the on-prem using hybrid link mode or SCX. You get a single pane of glass in hybrid link mode. In SCX, we can choose to perform the bulk VM migrations across the SDDC. And then we can leverage more than 100 plus AWS services on your existing on-prem workload without changing anything on your existing workload. So just choose, you can migrate them and then call all the AWS services on your existing workload. You don't have to refactor, rewrite anything on your existing workload or which you're running on premises. Just migrate them to VMware Cloud on AWS and you get exposure to all the services. So that's all we have for this session. We'll open up for Q&A now.
Yeah, so to answer to the previous question what Amit had, right? So whenever we have the raw device mappings to the virtual machine, how do we migrate? So even in the normal scenarios, you will not be able to migrate such VMs because of the hardware dependencies. And your hard disk or the storage is mounted directly, the LUN is mounted directly to the VM. So in such cases, first, one solution what I can think of right away is you can convert that into a VMDK and then move the VMs to some other place, like from on-premises to cloud or from one VC to another VC. But strictly, I think, to the best of my knowledge, you can't, straight away you can't migrate such VMs to one VC to another VC. But if anything is there, we can get back to you. But that's what we understand and we know that. Amit, you have any extensions for this question?
Guys, you can unmute yourself and ask the question if you want. We are open for Q&A now.
So Chidrup, I think if the vMotion is within the same vCenter server, so I think you can still do that with physical RDMs, but then it has to be vCenter 6.0 and the virtual machine hardware version should be 11 and above. So we do support vMotion of physical
Talking
RDMs.
about the storage vMotion?
No, it is normal compute vMotion.
Only compute vMotion. Yeah, compute vMotion may be possible. As you've told.
Storage vMotion, yeah, it's not possible. You'll have to convert into VMDK and then do that.
Yeah, compute vMotion, it's possible anytime, right? There is no hard dependency there. But when you have the mappings and dependencies, I don't think you can move that.
Right. Okay, so we have some more questions. Question from, okay, so there's an answer from Ravi Kumar.
Yeah, one thing what I can think of is he can convert, if he has any such hard dependency, like he has to move the VMs from one VC to another VC, then he can convert that into a VMDK first, and then he can
right.
move that.
So I think Ravi has also answered Amit's question. I will unmute everyone. 1 second. Unmute all. So I have unmuted all. If you have any questions, you can directly ask the presenter. So Amit, you are unmuted. You can ask questions now. Check.
Anshuman, there's one question in the meantime. I'll read out for you. It's in the chat window. So it is by Chirag Shah. He's asking, what is the surety that free hardware will be available during DR and it should be dedicated to the customer? How much charge for data storage for DR? As example, no DR in 3 years for 100 TB data. What would be the approximate charge? So I believe this is more around the concerns that what is the surety that whenever I need a hardware during DRS, elastic DRS, will it
can
be
you hear us?
Yeah, we can hear you.
Yeah, Chidrup, we can hear you.
Yeah. So the question is, what is the surety that free hardware will be available during DR, and it should be dedicated to customer? How much charge for data storage for DR? As example, no DR in 3 years for 100 TB data. What would be the approximate charge? Yeah, so half of the question I can take up, and the rest half of the question maybe Nitin or somebody can chime in and answer this. So the first thing is, like, no, it is not free. Like when you pay, right, as a service. Yeah, sorry for that. So when you pay for the service, disaster recovery as a thing, right? So you have to pay some amount there. And once you do that, you will get that hardware. And only when used, it will be charged. The extra thing will be charged. When it is not used, it will not be charged. And the second half of the question is, can you read that? Yeah, how much charge? So what is the charge per TB, right? So this part I'm not sure. Maybe Nitin, you have anything for that?
No, Chidrup, even I'm not sure. So I think you have different types of subscriptions in VMC on AWS. It is 1 year subscription, 3 year subscription, and maybe hourly subscription also. But I don't know the exact cost for it. maybe he'll have to reach out to the account team for this.
It also depends on which kind of storage or the platform you're opting for. For example, S3 has a lower cost compared to Glacier or other storage solutions. So this is generally can be more answered by the accounts or the salesperson who is dealing with that.
So Chirag,
Okay,
I would
we have
suggest you
noted down.
to reach out to your TAM, who will internally ask the sales team for this answer to this question. I don't think so. We have any more question to answer.
Amit, this side, actually, my question has not been answered yet. So I
Okay.
was telling that we don't have a space in our environment, and we have multiple VMs which is having multiple terabytes of data as an RDM. So how do we like follow for that? Is there any solution from VMware which they are trying to make that we can migrate the workload which is having this physical compatibility, or they have this as a limitation, or will remain
Yeah.
as?
So can we take this? Can we take this offline and get back, because we need to be precise and provide the correct solution. Because as of now, what I think is we can add up extra storage and convert it, but the storage seems to be very huge. So let me take this offline and get back to you guys.
Okay.
So Amit, who is your TAM?
It's Bhaskar.
Okay. So we'll try and get the answer for this, and then we'll send it across to you. But I think you'll have to use storage replication mechanisms to migrate your workloads, or maybe replicate the workloads across.
Yeah, we definitely need the extra storage there, but let's see.
No, if we don't want to like invest into our data center, and we are completely migrating it to the cloud, that is what I'm asking. So we don't want to invest more. We don't want to invest in any of the thing. Either it is
Yeah,
storage or
understood.
servers.
Understood, Amit. So that's where, right? So when you have that dependency, hard dependency, you really can't do anything. So you need to, what we can do is we can add up the extra storage to convert those things to VMDKs and then start moving to cloud. So that is one solution what I can think of today. But let me get back to you after discussing with other people as well.
Okay.
Yeah. Or as Ravi suggested, you can also convert that into virtual RDM first and then migrate to the cloud. Because we do support migration of virtual RDMs and VMDKs, but not physical RDMs. Okay, so I think we are already out of time. So thank you, Chidrup and Anshuman, for such an insightful session. Thanks a lot. We also appreciate the effort that you take to do this exclusively for the TAM customers. And I would like to thank everybody for taking out time from their busy schedule to attend this webinar. And you can reach out to your TAMs for the recording. The recording will be available just after this webinar is over. Thank you very much. Siddharth, do you want to add anything?
No, I think we're good. Thank you so much. Thanks, guys. Thanks for your time.
Thank you all.
Yep, thank you all.
Bye.